So if you're back at school and you're about to take Chem 20 or Chem 30, here are some of the things you should already know. And if you don't, let's go through it. So the first part is just understanding the periodic table. And what I wanted to bring attention to is pretty much this part of the periodic table, because if you don't remember, because you're given this booklet, you could always go here for some of that information. Okay, next slide, next one. Doesn't want to go yet. Let's see, there we go. So this is just the slide blown up. So this tells you everything you need to know. So you have your atomic number, so in this case number 26. Your atomic number will also always tell you the number of protons, so that will never change. In Chem 20, you'll start to learn about electronegativity. You have your element symbol, the name, melting and boiling point. You don't really use these, but I guess it's there to look at. Common charges. So if you were to gain or lose electrons, what would your charge of your ion be? And then lastly, it tells you the molar mass for 1 mole of the substance. So when you're looking through this atomic number, it does tell you the number of protons, and if it's a neutral atom, it would also tell you the number of electrons. So atomic number will give you protons, and in an atom, proton equals electrons. Then you also have the molar mass, and that is telling you the number of the protons and the number of neutrons that are within that atom. The mass of electrons is really, really small, so you don't need to count it. So when you are looking at an atom, you find the protons and the neutrons in the nucleus, and then you have the electrons that are floating around in those orbits, and all the weight comes from the center in the nucleus. So then looking at periodic tables, you hopefully remember this. If you're looking at a period that is horizontal, so going from left to right, and atoms are arranged in increasing atomic number. If we're looking at families or groups, that is going vertical. So when you look up and down, and they are arranged with similar characteristics. Metals are on the left side of the staircase, non-metals are on the right side of the staircase, and then you get metalloids, which can have properties of both metals and non-metals, and that is right along the staircase. Now, this is the groups labeled out for you. So this would be in your column 1. This is number 2. At the very end here, you have 18 and 17. Now, if you are moving on to Chem 30, you do really want to know what halogens and noble gases are. Not that we don't want to know the rest, but you will get questions that will say, like, name the halogen. You'd want to know that is something from group 17. We also want to know that all your other elements want to look like a noble gas, because noble gases are happy. They have full valence shells. So that outer shell of the electrons is at capacity. Now, looking at atoms, talking about this already, if you are neutrally charged, meaning you have no charge, you have the same number of protons as you do electrons, because they essentially cancel each other out. When you say that it's composed of subatomic particles, that's when we're talking about the protons, the neutrons, and the electrons. So protons are in the nucleus, they are positive. Neutrons are in the nucleus, they have no charge, and electrons are on the outside, and it has that negative charge. Neutrons can be calculated between the atomic number and atomic mass, both of which are on the data booklet. So if you want to find number of neutrons, it's always going to be the atomic molar mass minus your atomic number, because we know that atomic number tells you how many protons you have, and the mass is protons and neutrons together. This is just another way of showing it, because again, we know that atomic molar mass are both of these together. So if you take away just your protons, you would be left with your neutrons. Going on to ions. Ions, we know that atoms like to form ions so that they could look like noble gases, so that they get that full valence shell. If you have a cation, that means you've lost electrons, and if you've lost electrons, you would be more positive. If you have an anion, you have gained electrons, and if you gain electrons, you are going to become negative. So there are some examples here, and we can take a look at charges in a moment as well, because the periodic table does help arrange for that. But metals, they're going to be positive. Your non-metals, they're going to be negative. If you're going to name ions or atoms in general, you change the metal to IDE, and then if it's an atom, meaning no charge, it's just, like for instance, this one would be the phosphide ion. Then the next one you add ion just onto the end. So sodium, the atom, becomes sodium, the ion. So nonmetals, change the N to IDE, just like you would when you're naming molecular and molecular and ionic compounds. But again, we just want to add on ion here. So here's a little bit of practice with naming. And with this is mainly ions, but I'll add one on at the end to show the difference for an atom. So for here, your number of protons, just that reminder, it always comes from your atomic number, and that you get straight from the data booklet, right? It's going to be that corner value from every element. So if you're looking at the Scandinavian ion, it's this one here, it has atomic number 21. Now, if you are an ion, I know this is hard to see, but this atom's common charge is +3. So I'm going to write that there. And now we can never change protons. So once you have your atomic number and your protons, keep that the same, but we can change electrons. To have a positive charge, you need to have more protons than you do electrons. So we'd have 18 electrons here, right? So that would mean you have 3 less electrons, making you more positive with that +3 charge. So then in terms of the symbol, you would get that capital S, lowercase c, and you want to put a +3 because it comes with a charge if it's an ion. Now this next one, we wouldn't be able to figure out number of protons right away. We'd have to look at a number of electrons with the ion charge. So if it has a -2 charge, it means it has 2 extra electrons than it does protons. So if you have 18 here, we're going to put a 16 for number of protons. That will also tell us which atom we're looking at, which is the sulfur atom, or in this case ion, because you have a charge of -2. And then we can write that down. This will be sulfide, the ion. Moving on to that last one, which we have, I believe that's selenium. Selenium is number 34, so we'll fill that part in. If it's the ion and has a charge of -2, so we can fill that in, that means it has 2 more electrons than it does protons. So adding 2 more electrons to the protons we have. And then just to name this one, we'll have the selenium would become selen, sorry, one second, selenide ion. And then that last ion here, number of protons always tells you, atomic number tells you which one we're looking at. So if it's 7, that tells you it is the nitrogen ion. So the nitride ion. Nitrogen has a net charge of -3, and the difference between these two, you have 3 more electrons, so it would be negative. Now, the last one I wanted to add on was just the nitrogen atom. If you have just the atom, so any of these, not an ion, so no charges, then you would just write the N with no superscript because it has no charge. Again, number of protons is always the atomic number. Number of electrons and number of protons, if it's an atom, they are the same and there's no charge. So that's our first little bit, just practicing, looking at the periodic table, figuring out electrons based on the charge, right? And then again, just never change number of protons. That will always be the atomic number. You can only change electrons. Okay, moving on to naming. So if you are naming an ionic compound, because you know it's ionic because you have a metal, you name the metal first. So in this case, it's copper. And if you take a look at copper, there's a choice of charges. So over here has a common charge of +2 and +1. Now, chlorine always has a charge of -1. So when these two came together, it had to be copper 2 when we swap and drop to have that neutral atom. So here, to show that I know which one I used, I'm putting a 2 in Roman numerals, and then I'll add on chloride, changing that ending to IDE. Now, in terms of molar mass, this compound means there's 1 copper and 2 chlorine. So we would get the values, 1 copper is going to be 63.55, chlorine is 35.45, but this one needs to be multiplied by 2, and then add them all together. So this has a molar mass of 134 0.45. Now, this last part with mass, molar mass is always the unit grams per mole. So if I wrote this out and started with that 34.7 grams, I can multiply it by this value, 134.45. This tells you grams per mole, 1 mole. Now this is just a ratio, so if I want my units to cancel, I can flip that and say that 1 mole contains 134.45 grams. Now there is a formula, which you might remember, but I just like to use unit analysis because that's all you'll be doing in Chem 30. You would never use the formula, or you would, but then you carry on with unit analysis. So this shows you your grams will cancel. You plug this into your calculator, 34.7 times 1 divided by 134.45. And based on sig digs, we'll just keep 3, and we should get 0.258 moles. Okay, moving on to the next one, zinc sulfide. That tells you zinc has a charge of +2, right? You can get that straight from the table. So zinc is here. Sulfur is here. It's in, so that's one thing with Chem 20 and Chem 30. The data booklet doesn't tell you the nonmetals charges. So just going through that, noble gas is always a 0. So all of these have no charge. Then the group 17 has a charge of -1. So all of these, -1. Beside that, -2. Beside that, -3. And then we stop there. So because sulfur is in the column with -2, we know sulfur's common charge is -2. Now, if you swap and drop and then reduce, you only need one of each to make a neutral atom. So when it comes to the molar mass, you want to add 1 zinc with 1 sulfur, and doing that, you would get 97.48. And then same setup. If you started with it 885 grams and you multiplied it by your molar mass, but you'd have to flip your ratio. So 1 mole is 97.48 grams. You can multiply these two together to get your moles, and that's going to be 9.08. And I just kept 3 sig digs once again. Now, HCl, anything that starts with an H is an acid. And in Chem 20 and Chem 30, you can just look at page 8 and 9 of your data booklet and see that this is called hydrochloric acid. If you don't want to refer to page 8 and 9, then you just have to remember the rules of naming that you would get when, like, so if it ends in ic, what do you do? If it ends in ite, what do you do? If it ends in ate, what do you do? Now, when I teach Chemistry 30, I always say you have enough to memorize. Just use your data booklet because you have it. But if you love naming, go ahead and do it the way you've learned it. And then adding your molar mass, you have 1 hydrogen with 1 chlorine. That's going to be 36.46. And now this isn't giving us any calculation to do, so we could just say what this means. So 36.46 grams per mole means there's 1 mole and 36.46 grams. Now, if you change the moles or you change your mass, you would be able to figure it out. Now, this next one gets a little bit complicated because you have potassium, and then you get this more complicated polyatomic ion. So if anything looks kind of, I like just to say weird, check your polyatomic ions because you will find it. I think I just crossed it out here, but you will find it there. So this is potassium dichromate. When you add this together for your molar mass, you want to add 2 potassium, 2 chromite, and 7 oxygen. If you do it correctly, or if I did it correctly, you should get 294.2. Again, that is grams per mole. So with this one, when you want to find mass, if I start with my moles, 0.0125 moles, I can multiply it by that 294.2 grams per 1 mole. So now your moles cancel. You can plug that into your calculator, and you will have I'm just doing 3 sig digs once again, 3.68 grams. Now the last one is a molecular compound where you have 2 nonmetals, so you have carbon dioxide. If you have no prefix in front of the first nonmetal, you just assume 1, so it's 1 carbon. Di means 2, so CO2. Now, getting your molar mass, add 1 carbon with 2 oxygens, right? And you get 30.01 grams per mole. And now we can set it up similar to this last one. You start with your moles, 6.75 moles, multiply it by your molar mass, grams per 1 mole. Moles is in the denominator, so we didn't have to flip anything. And you get this number, 202.56. So to keep 3 sig digs, I am just going to bump that end one up to 203. As always, I hope this helps. This is definitely more beginner chemistry in high school, and then you would move on and use this information in Chem 20 and in Chem 30, and it would just be expected you know it. If there's any other video I could do for you, just let me know, and as always, please subscribe if you made it this far and you found it helpful. Thank you for watching.